Good day, everyone. Today, I want to present the poster with ID AG2B001. Topic of the presentation is influence of cobalt doping on the morphology, vibrational, structural, optical, and manganese properties of copper oxide prepared by microwave radiation. This work was made en la Facultad de Ciencias Básicas, Departamento de Química, Universidad de Córdoba, Montería, Colombia, by Gustavo Jaires Beltrán and Carlos Osorno. Now we're going to go over the introduction. Copper 2 oxide. From now, copper oxide has monoclinic structure belonging to the telluride 5. It's a p-type semiconductor with a gas in the range of 1.2 to 2.2 mV. The oxide has high electrical and thermal conductivity, chemical stability, and multifunctional application ranging from photocatalysis to gas sensors, solar cell, light emitting diodes, antimicroactivity, electrochemical, among others. This potential application can be improved when the semiconductor oxide is doped with a few amounts of transition metal. These systems are now as oxide dilute magnetic semiconductor. Additionally, the cobalt doping is beneficial for optical, electrical, and magnetic application for functional spectrometry devices. In this work, we have prepared cobalt doped and copper oxide sample by a sample efficient of fast metal and the variation in several properties as a function of cobalt concentration are studied in detail. Experimental procedure. Cobalt doped copper oxide sample from 0 to 5 molar percentage cobalt were prepared by copper precipitation method assisted by microwave radiation. First, copper 2 acetate and cobalt 2 acetate were dissolved in ionized water and mixing for 30 minutes. Then the pH was adjusted to 11, adding sodium oxide 1 molar. This solution was stirred for 30 minutes. The precipitate form was placed in a domestic microwave oven for 18 minutes using half power. This oxide formate was centrifugated, washed with ethanol acetone, and dried for 70 Celsius degree for 24 hours. The sample was characterized by scanning electron microscopy, field emission scanning electron microscopy, STR, Raman, ISRD, UVB absorbance, UVB diffuse reflectance, and magnetic measurement. Result. Field emission scanning electron microscopy. Copper sample revealed the formation of irregular falciform nanosheet with 2D structure with high roundness. For the sample with higher cobalt concentration, was absorbing this nanosheet pileups in parallel, evidence 3D structure, indicating that cobalt atoms induce the agglomeration. Vibrational technique. This technique evidence that an undoped sample exhibit a typical vibrational modes belonging to crystalline copper oxide 5, corresponding to the oxygen-copper oxygen bond. When increased cobalt doping achieves a lower weight number is observed, indicating the incorporation or replacement the ions cobalt into the copper oxide structure, modifying the vibrational modes. ISRD of undoped copper oxide sample showed only peaks belonging to the monoclinic structure titanuride. In cobalt doped copper oxide sample, the peak associated to cobalt 5 were not detected. The cell volume gradually decreased in the doping level, indicating substitutional cobalt 2 plus for copper 2 plus into lattice size and copper oxide structure. The average crystallized size increased in the sample with high cobalt concentration in comparison to the pure copper oxide sample. The results are in agreement with field emission scanning electron microscopy. UV absorbance. Pure copper oxide samples show oxygen bands associated to charge transfer transition. The red sheet in cobalt copper oxide sample is due to the incorporation of cobalt 2 ion in the lattice structure. The change in the current cavity can be ascribed to the change in morphology from 2D from undoped sample to 3D for the sample with higher cobalt concentration. We can see that the band gap decreased with increased cobalt concentration. This gradual decrease might be mainly to the chain interaction between the localized d electrons on the cobalt 2 plus ions and the S and P electron of the host bands, the semiconductor. Magnetic measurement. And though copper sample events with ferromagnetic contribution, we now learn a parametric contribution, where the coefficient field and material saturation and cobalt copper sample decrease when the increased cobalt content. With ferromagnetic component and pure cobalt oxide nanosheet is associated to uncompensated spins on the surface and decrease in saturation magnetization, and the cobalt sample could be associated primarily to surface side effect. Conclusion. We have prepared cobalt copper sample by a fast and efficient method without depressing the secondary files. STR, Raman, and early result indicating that cobalt 2 plus ions were introduced into the cobalt copper oxide crystal lattices substituting copper 2 ions. Field emission scanning electron microscopy on baby spectroscopy reveal change in the morphology from 2D for the pure sample and 2D, 3D for the 5% cobalt doped copper oxide sample. UV diffuse reflectance spectroscopy show a reduction of the band gap with increased cobalt concentration. The change in magnetization of the sample could be due to surface effect, where coercive field and the saturation magnetization depend on the particular size and shines. Thank you for your attention.